Hello, my name is Gsell, and I'm here to talk to you about what I did this summer for my summer 2023 internship as a software developer at FSCJ. We got a lot accomplished and we did a lot this summer, so let's dive in and see what we did. So this summer, what were the goals? The goals that we had was to create a pseudocode linter that picks out the problems or mistakes inside student Gaddis pseudocode, which is a fake code that you use to just kind of plan what you're going to do exactly. And the steps for this whole process, well, one, our group was starting from scratch here, so we had to pick a name for the program. We had to set up visual boards for planning and collaboration. We had to understand what the input and output that we wanted was, and the input could be all kinds of things. We'll get into that later. So step four, we had to divide up the problem into smaller, more manageable tasks, and then we had to finally write the code, test the code, and then you repeat steps four through six as needed. So we'll dive into exactly what I did individually this summer and then the project as a whole. So after a brainstorm, our group finally landed on the name Succulent because it is a pseudocode linter, and pseudo is with a PS. And then we altered the name Lint because it is a linter. And we had a little logo made up really quick just so we could put it on all future documentation and just kind of have a little bit of a brand on the logo for future purposes because I believe this software is going to go far. Right. So our second step for the process was to set up visual boards for planning and documentation, and just to keep everybody up on the same page of what everybody's doing. Here's a screenshot of a section of one of our Miro boards. We ended up using Miro. It's a great software. Recommend it to anybody. You can move your mouses around together, touch the whole thing. It's as if you're in the same room together. I had a great experience with this, and we were able to just kind of keep on the same page and also document the whole project as we went along in this whole process. So for step three, we wanted to understand the exact input and output that we wanted for this program. We wanted to know exactly what it would take in and what it would reject, what it would output with the exact information that we wanted from each file. As a software developer, I've learned that this helps you stay on track for the whole project. It's very easy to be halfway working through it and see a possibility for a feature or something really cool, and you get giddy and you want to add it in, and it actually sidetracks you from completing the base project, which was the original goal. So it can be feature creep as it's known, and it's very, you have to watch out for it. And this knowing what you want your output to be immediately really helps you stay on that path. And so we wanted our program to accept docs and text documents that have data pseudocode in them, and then output the problems found to the console, and also a text document that one has the pseudocode with line numbers next to it, and two with the errors also in it. And we wanted two different versions of output for this program. We wanted a version for students that would give them the amount of problems they have in their code first. So they could run it once. It would say, hey, your document has 4 problems in it. Can you find these problems? And if they run it again, if they can't find all the problems, then it will actually give them where the exact errors are. But we wanted students to have a chance to figure out the problems that they made and understand what they're doing and understand the problems or mistakes that they've made. And the second version would be for teachers and professors to actually grade assignments. So you could just feed student problems in or student pseudocode in, and it would spit you out all the problems if they have a misspelled keyword, um, anything. It just makes the grading process much easier for teachers and can also be used as a learning tool for students. So we were extremely excited about this kind of dual functionality for the whole thing. So here's what we had as an example input for our original process on the board. So you can see here we have the little, there's a missing close statement for this for here. There's no for closing statement. That would cause an error in real code. And this is data pseudocode, by the way. This is an example document of what we're looking at here. And over here would be a misspelled keyword, functions misspelled there. And we wanted it to catch that because mistypes are very easy in this kind of thing, and that will cause code to break. And the missing return statement for a function, it's not returning anything that it needs to. So this was just an example input that we created. And this is what the kind of either text or docs file that we wanted input into our program. All right, so on this slide was our example output that we wanted here. So you can see for the student section on the first submission of their document, the program will spit out, hey, your code currently has 3 mistakes. Can you find and correct them? We thought this was extremely important for students to not just get the answers for their problems, but to be able to see that there are problems in their stuff and figure out, give them a chance to figure out for themselves, what are the problems? Where is the error in my logic? This kind of a vague, like, this isn't perfect, go out there and find those treasures, if that's what you want to call them. And then if they search high and low, they end up finding 2 mistakes, and they're like, I cannot for the life of me find this third one. You can run the program a second time, and it will detect that it is the second time for the student running. And it'll say, hey, on line 16, you're missing the close for the for loop, or any other errors they have in there, just to specify and show them what they did wrong. And for the teacher and professor output, it would just straight give them the answers, because the teacher or professor knows these mistakes. They're not trying to learn it. They know this stuff. They just want, what did the student do wrong, and how do I take these points off of their grade? So we were really excited about this dual functionality for it. Right. So step 4, breaking down the problem. The first thing that we realized we had to do was first get the docs or text file parsed into our program. So our program is able to read it. Our program is in Java. We need to get it into the Java code so that we can actually read the text that we're given. So then once we get it, we'll break down each line that we're given into something that we can end up scanning for various problems, and then end up attaching each error to each line. And you can add possible suggestions for a fix to the error in the code. So it would, maybe give out a link for documentation or something like, hey, this is how for loops work. You're doing it a little bit wrong here. Here's a get a pseudocode document, and that'll give you, kind of point you in the right direction from a student perspective. And then it would output the results with a version of the pseudocode that has line numbers, because the original text document, you're just typing in the pseudocode. But if we say, hey, your error's on line 7, it would stink to count down the line individually and just 1, 2, 3. Okay, it's that line right there. So the text file includes line numbers just to make the review process easier. Finally reaching step 5, write the code. So my first assignment was to make a class that will parse the docs or text file into our program so it can be read. I ended up finding a third-party library called Apache Tika that would let us bring in all kinds of documents, more than just docs and text. I only included docs and text because that is the limited input we wanted. But this is great for the future if they want to add functionality, if you want to be able to also accept PDF files or just a long number of things. And I have the web page for Tika that I had found. Incredible library, incredibly detailed. I did a lot of research to see exactly how it worked and how we could get the file in there. It is so much larger than what we actually use it for, and I believe it can help the project and be expanded in the future because it is a very powerful library. And I have an example of my code that I wrote. It's just a part of it. It's in Java. It just says, create a temporary text file, read the text file from it, and then be able to, this is the code that just parses it into the program, and it figures out if it's a docs or text file. And it just throws errors right here, real simple. But that was my first assignment. It was very exciting. A lot of research made me realize how huge documentation can be and how exciting it can be to sift for kind of that functionality that you want in a haystack of documentation for a third-party library. But once it was in and working, it was great, and it came out working very smoothly. All right, so second assignment for write the code for me personally. Once we got going and once we were able to parse the code into the file, we realized that running and testing our stuff on multiple files would take quite some time because our program grabs one file individually and it scans through it, spits you out the stuff. But if we want to test our functionality, running it on every individual file would take forever. It was very time consuming, very tedious, just to make sure that our logic and everything was right. So my assignment was to whip up a bash script that would actually run our program on all of the Word or text documents within a file, just to kind of prevent the tedious, we want to test our functionality on multiple things to make sure that it catches multiple types of errors there's infinite things that can go wrong when somebody can input anything into your program. So just to speed up the process and make it easier for the developers, I came up with this bash script that just grabs all of the documents in the file and runs our program on it. So with one command, you can run as many files in a directory as you want. And that just, we were all very grateful for that once it was completed. And here's an example over here. So you would run this program on this directory and it would only have the Word documents in it. And it ends up spitting out these succulent result text files on all of them. So one command made it real simple. It's very fun. I'd never done bash script before. Very cool to learn, very different syntax. And once it was done, it was great. It's such a useful tool. Um, so step 5 again, I had another assignment given to me, and this assignment was to create a Java class that would check for Gaddis keyword misspellings. And if you're not familiar with it, a keyword is just kind of a syntax for the language itself, like something you can't use in your custom names. Just so there's a set amount of rules, and each word, tells the program, hey, they're doing this right now. So you can't use it for your custom variables or anything like that. And after research, I came across this third-party library, Apache Lucene, very powerful. It can actually be used to check words against entire dictionaries, entire languages, very broad, it's very efficient, and I was able to inject a custom dictionary, which for us was just a very short list of Gaddis keywords. And it actually is powerful enough to suggest the correct word that it believes you're trying to say. So if you in your code say, leave out a letter by accident and say content, so this will pick it up and they'll say, hey, I see that there's content here. Did you mean constant? Because that's a keyword, but content isn't. And I was able to implement that into our succulent. This is just part of the code that I wrote. There's a lot more behind it than this. This was just the main section that scans, but it was a lot of fun. This third-party library is extremely powerful, and it is capable of so much more than we use it for, but it does it so efficiently and so well. And I had a lot of fun doing this part of the assignment this summer. So once we had enough code down for a partially functioning program, we really wanted to run it through the ringer just to make sure all our logic was good and that you could throw anything at it. We want a resilient program. So we were lucky enough to get a group of testers together. David Singletary helped us pull together a group of people, and we were able to create this form that would give them like a quick how to use guide for our program. We set it up real easy so they don't even have to know Java to run it. It's a quick bat file that will run it for them. So just kind of like open it up, is your file in there, or you can insert the path to direct it to it. And we had this first test. We did a number of test assignments with them. I believe we did 3, and this was the first. And then we gave them a form. And every time they would run the program, they would fill out this form. It would say if they broke the code or not, and we would be able to see exactly what happened if they did. We actually ended up getting a lot of useful information this way, and it allowed us to really fortify and make our program very resilient in the stages that we had down. So we were able to communicate with our testers. We set up a Slack channel and we were able to give them their files and receive their feedback all through Slack. We wanted to keep it really simple because it was a smaller test group. We were able to ball rolling that way. And here's just an example screenshot of exactly what was going on in the communication. All of our testers were very clear. They wanted to help us in this. They were very eager to. I feel very lucky and fortunate that we had a group of people that were really willing to do where we told them we wanted them to do strange things. We wanted them to throw any kind of input at this that we hadn't anticipated. And boy, did they find it. So we got a lot of feedback from that, a lot of great feedback. And we had a lot of fun doing it, a lot of great people in this project. And at the end, step 7 was repeat steps 4 through 6. So you just keep reiterating, breaking down the problem smaller. You plan it out with your workers. You write the code, and then you test the code, and rinse and repeat until the program is done. Is what I've found really for the whole process. This summer was much too short to completely complete this program. We got so much done and started from nothing made a great foundation for this program to be built off of. I hope a lot of people work on it in the future and expand the functionality because I can see this software being so useful to both students and teachers in the future. I think it has so much potential, and I hope to work on it a little bit more and continue to support with it and deal with anything that comes with it, introduce new people. So we're just going to keep chugging along and trying to fix the problems that we come across as they break and also implement new functionality because it is far from all there, but what we have down is very solid and very well tested. And I'm very proud to show this slide. This is the end product that we have so far. This is going to be so much bigger when this whole program is done and launches for people to actually use it. We had a lot of fun planning, a lot of fun implementing, a lot of fun really learning the full process. We were also excited to learn all of these things, and David Singletary just did a great job of kind of pointing us in the right direction when we needed it. Sobrato was also involved for some suggestions in the beginning. And this was just such a fun experience, and you can kind of see the complexity already starting here. It is such a so much goes into every program that we use every day and take for granted, and so much thought goes into each little bit, and it's been a great experience. This, but as you can see, this is the end product so far. It's not the final. This is just what we have at the moment. This is a diagram showing all the things that go into this, all the little moving parts and bits that the little bit of functionality that we do have at the moment. And that was pretty much my whole summer 2023 internship with David Singletary at FSCJ. A special thanks slide. Thank you, David Singletary, for being an incredible person, mentor when we needed it. You had this idea to begin with and pointed us into how we could implement the base stages and where to go from there. And Professor Brada, thank you so much for your suggestions and input early on to really help us organize and get together, and your general interest in the whole program throughout the whole summer as well. Thank you to all the programmers and people that I worked with. I know all of our summers were very busy and hectic, and we got so much done, and I am so grateful to have met all of you. Thank you for each tester that participated in our group. If you watch this, I appreciate every form you filled out and every test you ran, and taking the time out to help us really foolproof this program and throw the whole house at it and try to make it as resilient as possible for students and professors in the future. I have had such a great experience this summer. I've learned more than I ever thought I was capable of. And I realized that we are all human and there's so much knowledge out there and we can all learn so much from each other. And it's been a great experience. So I had a great summer of 2023 at FSCJ doing software developing internship. And that's my presentation. I hope you have a great day.